Hello, my name is Stan.
Hi, my name is Donat.
And you might be asking why we have three different laptops placed on this table today. And the reason behind it is that we will be discussing a very interesting topic called hardware fingerprints. We will first of all talk about how websites can use hardware fingerprints for identification, and then we will discuss on how you can most effectively utilize them in your everyday activity.
So let's first talk about most popular hardware fingerprints. We have three fingerprints called Canvas, WebGL image, and AudioContext. And they work more or less in a similar way, but let's explore why at all we have those fingerprints. Many people think that those fingerprints are basically hashes that they see on checkers like browser leaks, but that's not true. Hashes are just a representation of the original fingerprint, and the original fingerprint is not some value or parameter. It can't be replaced. The original fingerprint is basically how your graphic adapter or audio adapter processes some task. Let's see how it works. For the sake of simplicity, we have an article on our blog, and for the sake of simplicity we only explore two reasons why different computers produce different results during fingerprinting. And let's see what are those reasons. Now we can see a scheme for font hinting, so-called font hinting on your screen. Font hinting is basically a special instruction that helps rendering algorithm to draw a character on your screen, because characters in your on your computer are stored like mathematical formulas. They are not stored like images. And when a computer tries to draw this mathematical formula on a screen to display this character, it should render mathematical formulas into an actual image consisting of pixels. And depending on your screen parameters, depending on resolution and the size of dots and so on, the result may be different. And hinting is basically an algorithm that helps computer to properly display this font, to properly transform it from mathematical formulas into an image. As you can see, here are two options how it can work. For example, we have the same character M. Is this simplified simplified image? Of course, in real life it's a little bit more complicated because characters have more pixels. But let's see on this simplified example. For example, here this pixel can potentially be located either a little bit upper or a little bit downside. And depending on how it is located, the end result will be different. It won't be noticeable for a human eye in most cases, but computers will see the difference. And if we created two images on if a browser rendered the same task on different computers, and in the first case it got image 1 as a result, which you can see on the left side, and on the second case it got image 2, which you can see on the right side. The hash of such picture will be different, because a hashing function reduces the amount of information that is there, but if the information source has a little bit different information, if there are like slight discrepancies, the resulting hash can be completely different. Another way why these discrepancies happen is a thing called anti-aliasing. Anti-aliasing is basically smoothing edges between contrast objects. This is done so you don't see a staircase of pixels between different objects. And the most simple way to demonstrate this is on a black and white image. On a black and white image, contrast edges are being smoothed in a way by adding gray pixels of different tones. And if you perform the same operation of anti-aliasing on different graphic cards with different drivers, the result might be slightly different. You won't see the difference with a naked eye, but if you explore the small pixels small dots in detail, it may turn out that the tone is slightly different. And once again, this difference cannot be seen by human eye in most cases, but computer understands that very easily. So this is why these discrepancies happen on different machines, and it's important to know that different graphic cards are likely to produce different results. Audio fingerprinting works the same way, with the difference that websites do not ask your computer to draw an image, but ask to play some sound. And once again, different audio cards add their own discrepancies into the end result, and this is where this difference of results between different computers stems from. So being rendered on different computers, the same task will produce a different end result. And here what we can do to replace that fingerprint is we can slightly modify that result. We call it adding a noise to the result. And even though we can add a persistent noise every time to the result, it still can be detected. For example, if the same fingerprinting task is given to millions of users, then some of those users will have the same hardware, the same setups, and the website will receive back these results in the form of hashes. Hash is basically a simplified, reduced form of some information. The website will get back these results, and then it can compare different users, like what they sent. And it will turn out that some users sent the same result, while some other users have unique results. And these users with unique results, we cannot say that they altered their results, but it's possible from the website's point of view that the results have been artificially altered.
A very excellent example can be seen on browserleaks.com/canvas. You can actually go and see it for yourself. If you navigate to this page, you will essentially see this image file details. It's basically the task that the BrowserLeaks website asks my browser to draw. And of course, in the wild, this image will be hidden. You will not be able to see it, but basically it will draw this image. And then it will compress this image and turn it into a signature or hash, which it will use for further analysis. We can actually see a good example of what Donat has just described is that different machines will have a different result, and sometimes it can be even seen with your eyes. You can see that that BrowserLeaks made a GIF, an animated GIF which basically shows different results on different computers. And here you can also see the task that the browser asks. And the thing is that when Donna told that websites can at any point change the task, and they can even change one small thing here in the task, and the end hash will be different. So that's why we don't store these hashes. It's just not a good long-term solution.
Yeah, it's basically pointless. You cannot replace it on a hash level. If you replace it on a hash level, first it's quite hard from the technical standpoint, because you need to know which hash it uses and where exactly the hash calculation happens. And second, it's pointless because it will always be seen. This change can be easily detected by the website. On the contrary, changing the result of fingerprinting task, like adding this noise, is not that easily detectable, albeit it can be detected to an extent through statistical analysis.
So okay, we have this very notoriously dangerous method of user identification. What does MultiLogging do about it? Essentially, MultiLogging has protection against hardware fingerprints, Canvas, WebGL, and audio. And what it does is that it adds a persistent noise in the on the browser, on the Canvas readout itself. So when the task is made, MultiLogging adds noise to this task, and thus the end hash is different. So, and from this method stems two very important considerations. And the first one is that when this method is applied, your canvas or WebGL hash will be 100% unique.
Yeah, it's not necessarily very bad because those canvas, WebGL image and AudioContext are just a few small pieces of the whole fingerprint puzzle. So even though they may look as having some discrepancies from the website point of view, it's just a few pieces of the whole puzzle, so it may not necessarily hurt you.
The second consideration that we need to take into account when using hardware fingerprint masking is that it applies a consistent filter, but it's only a filter, which means that if you open the same browser profile on different computers, hash will be different on these computers, although we apply a persistent noise. I'll show you an example. For example, Donut's face is the canvas task.
Canvas fingerprint.
Donut's face is the canvas fingerprint. And I apply a red filter on his face. Okay, now the face of Donut is different. However, if I place this filter on my face, yes, my face is red, but the thing is my face is different, so the readout is also different. Although when MultiLogging utilizes this protection mechanism, it applies a consistent filter. However, the initial hardware readouts are different. Hence, the end readouts that the website sees even with hardware fingerprints masking on will be different.
Yeah, this has a consequence that if you want to get the same resulting fingerprint, you need to apply the same persistent filter on the same face, and we'll show you later how it can be done in real life.
Yeah. So what can we do about these two problems? The first one is uniqueness, and the second one is that on different computers the hash will be different. For uniqueness, the best way at the moment is to disable hardware fingerprints at all. If 100% uniqueness is something that really bothers you, then you have the option to completely disable them. Here you need to understand one thing, is that if you do turn off hardware fingerprinting masking off, then your real canvas signature and WebGL signature will be given out to the website. However, it shouldn't be considered as a complete kill for your browser profiles and identification, because as Donut told, different computers will have different results, which means that if you do allow websites to see your real canvas hash, you will still fall in some distribution of users that have the same canvas hash.
Yeah, depending, even if you don't enable canvas, AudioContext and WebGL masking, depending on your computer, the segments that you fall in can be very large. For example, many modern computers don't have only integrated graphic adapter and have integrated audio adapter, and this integrated adapters are very common. For example, some Intel adapters are sold in tens of millions, if not hundreds of millions. So if you have a laptop with this kind of adapter and you leave canvas and WebGL and AudioContext image unmasked, fingerprints unmasked, then you still will fall in such a large segment of users that websites won't be able to uniquely identify you out of that segment. And given that you also have other different fingerprints like navigator object and media devices and so on, you'll still have enough uniqueness to have hundreds or thousands of browser profiles, and still websites won't be able to link them together.
This is especially prevalent on MacBooks. The reason behind it is that MacBooks are typically created with the same hardware, with the same OS, of course, and with the same settings and configurations. And this is why we have these two MacBooks right here placed on this table, is that we want to showcase this specific example. I do want to point out that these two MacBooks are not exactly the same. They are a bit different model and a bit different here. However, they still have some parameters which are identical. And let's take a look. So let's take a look first of all at the MacBook number 1 and go to browserleaks.com/canvas. We'll take a look at what is the Canvas signature here, and it ends on
231. And I want to point out that this is not a multi-logging browser. This is we are checking the real Canvas fingerprint of these MacBooks.
And let's do the same on MacBook number 2. We'll go to browserleaks.com/canvas. And as you can see, it also ends on 231. And although these MacBooks are slightly different, they're still, their Canvas readout is completely the same. Which in turn, if we take a look at the Canvas readout for this Dell right here, it will be completely different.
Yeah, it ends with 236 instead.
The same story for WebGL. If we go to WebGL, and we go to WebGL on the second Mac as well, and we'll take a look. You may already see that the WebGL image hash is the same. And the reason behind it is that this WebGL image is rendered in the same way on both MacBooks. However, the WebGL report hash is slightly different. And this is very likely due to the fact that these two MacBooks have two different graphics cards installed. So here we have graphics 550, the Intel one, and this one is graphics 640.
Yeah, but the interesting thing is that these two different graphic cards still renders the task in completely the same way, which may mean that they at some level maybe they have some dedicated chip for that task, or maybe only like first one or two chips activate for the task and also utilize the same driver. So that might be the reason why the result is completely the same, even though graphic adapters are obviously different in this case.
So look, we took two slightly different Macs, even more than slightly different Macs, and the end readouts are the same, which basically implies that if 100% uniqueness bothers you and you want to be less and less unique and to fall in the larger segment of users, you may use Mac computers and turn hardware masking off, which will place you in a large segment of users and will be more difficult for the website to specifically identify you. The second problem with the whole masking mechanism, the second issue consideration is that on different PCs, when you open the same browser profile on multiple different computers, the readouts will be different. The filter, when I told you, what can we do here? Essentially, as you already understand, you may use MacBooks for this because the initial Canvas hashes are the same, and when we apply the filter, the face is the same, so the end readout will be also the same.
Yeah, but I would like to add here that MacBooks are not mandatory. You may as well use some other laptop, just make sure that it has the same graphic adapter, the same audio adapter, and also the same operating system and drivers. Maybe if you install latest Windows 10 and update the drivers to the latest versions, then you're all set.
Let's give an example. Let's open the same browser profile. So I have the same browser profile opened on 3 different laptops, and let's launch them on 2 MacBooks and 1 Dell for comparison.
Yes, and in this browser profile, Canvas fingerprint is obviously masked. So we are right now we are looking how this noise filter is working on different devices.
Let's open here. Okay, let's go to MacBook number 1. Because filter is applied, uniqueness is 100%, and the signature ends with A54. Let's open the same browser profile on Mac number 2, and uniqueness is 100%, and the hash is absolutely the same. However, if we open it on Dell, a different PC, then we will have a different signature as well.
Once again, uniqueness is 100%, but the signature, the hash, is different from Mac's.
Finally, what we would like to tell you regarding this whole commotion is that you do not necessarily need to use Macs or similar models of computers. You may also use virtual private servers. You may order few VPSs from the same VPS provider, configure them in the same way, install the same drivers, install the same OS, and you will see an absolutely the same picture as you see on these two MacBooks. So that's one of the solutions that you may use, one of the alternatives to Macs or different computers.
And the final question is why it's all so hard? Why cannot we just make magic button that you could press and make everything work and make everyone happy? And the reason here is that this technology hasn't evolved that far yet. We are perhaps the only or maybe the first team in the world that is moving this technology forward. So we are working hard to bring this technology to life, to allow simulating real user canvas, real user audio context and WebGL, but it will still take some time until we reach that point where we are able to do that. Until that time, you'll have to be creative about it and maybe utilize one of those methods that we discussed today here. But I hope that rather sooner than later we will be able to present you with a prototype and maybe with a working solution that would simulate real user canvas and WebGL and audio context.
If you're watching this video in the future, maybe we have already developed this technology. And if we do already have this technology, then the links will be below, and I think we will have a separate video on this. But for now, we urge you to go and subscribe to our Telegram channel. We have Telegram channels both on Russian and English. There we will most likely post the information about this canvas when it's ready, and also we post a lot of different useful information there as well.
Yeah, and also hit the bell near this video, because then you'll receive our new video right to your mobile phone when it's out.
Thanks very much for watching. We hope that this was useful to you and you can apply some tricks that we've discussed here.
Yeah, have a good day. Bye bye.
Bye bye.